Good morning. We're here in the laboratory today. We're going to be doing a very interesting experiment about the pH, which living things live and thrive. We've got our lab book handy, we've got our instructions handy. We're going to need a couple other things. We're going to gather them up and we'll be back in just a minute. We've got our materials gathered up that we need here. If you look at our instructions, okay, we see that we need a graduated cylinder. Okay. It's called a graduated cylinder because it has these marks on here, and these are called graduations, little tiny marks on here. Each mark is 1 milliliter. Okay, so it goes from, they measure from the bottom up usually. This one has 1 down here, so 2, 3, 4, 5, all the way down up to 10, okay? We've got ourselves some pH paper right here. pH paper, that's what we're going to be using to test the pH with. We've got some lemon juice, which we should remember is an acid. And we have some ammonia, which we keep covered up because it smells really strong. And the ammonia we should remember is a base. We've got ourselves a dropper here. We got some distilled water right here. And we have a little tiny 10 milliliter beaker. That's kind of cute, huh? All right, so we're going to be using these today. And so let's get started. Okay, before we get rolling, I want to talk about the meniscus and the graduated cylinder. Remember, we said the graduated cylinder has these little marks on here. Well, how do we measure? You might remember that if you have a straw or any cylinder, that when you put water in, the water does not just go straight across. The water curves, or the liquid curves like that. So would this be 5 milliliters or would it be 4 milliliters? Because 1 is down here. You go 1, 2, 3, 4, 5. There's 4.5 and there's 5.5, 5.5. So how would we measure how much water? So do we measure at the top of this curve, or do we measure at the bottom, or do we measure in the middle? Okay. The answer is we measure at the very bottom right here. This is called the meniscus, okay? The meniscus. The meniscus is a curve like this. Now, you've probably heard about the meniscus in your knee or someone's knee that they tear and they have to have an operation. That's simply because the cartilage in the knee is curved. So they call it the meniscus. The medial meniscus, the lateral meniscus, but it's a curve like this. So we always measure the water at the bottom, or any liquid, at the bottom of the meniscus. pH paper. You can see on the pH paper that we have right here on our little chart, we've got 0 and we've got 13. On a pH scale, remember 7 is neutral. The higher the number, it goes up to 14. Higher than 7 is a base. Below 7 is an acid. So we're going to be using this little chart to test our solutions that we're going to look at today in our experiment about pH. And we have to refer to this little chart to do that. Now, pH paper is kind of expensive, and we don't want to pull out a piece that's like 6 inches long or 14 centimeters long. We want to pull out just one small piece like this, and we can use it to dip into a solution, and then we compare the color change to our chart here to determine what the pH is. Now, one thing about pH paper, the color of it can change by something in the air. For example, if we take the ammonia right here and we take our little covering off the ammonia and we just hold the pH paper over the top, it's going to change color. See how it changed blue or greenish color just from the fumes coming out. So the pH paper, something like, if we're using pH paper, we have to keep something like the ammonia covered up so that the fumes can't get out. And also, we don't want to tear off a piece of our pH paper and just lay it on the table and wait till later to use it. When we use pH paper, we take it out, we tear it off, we dip it in, we shake it off real quick, and we check it immediately, okay? We don't want to wait. We don't want to set it on the table and wait. I've seen students before, they'll take 10 pH papers, test 10 things and put them on their table, and they're going to come back and check them later when they get it all done. Well, by then, the pH color on the paper has changed. So we want to keep that's why it's inside this little plastic container. We want to keep it inside the plastic container as much as possible, because we get it out, even the humidity, the moisture in the air can cause our pH paper to change. So our instructions start off, they say pour 5 milliliters of solution number 1, which is milk, into a beaker. Test the solution with pH paper. Draw the table below in your book, in your lab book, and record your results, okay? So we got to take our graduated cylinder, and we need to measure out 5 milliliters of milk. So we're going to take our graduated cylinder, and very carefully, we're just going to pour in 5 milliliters of milk, measuring at the bottom of the meniscus. Now, the milk we're using is dehydrated milk, okay? I went a little bit over there. So I'm going to take my dropper, I'm just going to stick my dropper down in here, and I'm going to suck a little bit out until I have exactly 5 milliliters of milk, okay? I'm going to pour it into a little beaker. So we got our little 10 milliliter beaker here. We're going to pour 5 milliliters of milk in there. I want to make sure we get all the drops out, because 1 drop is 1/10 of a milliliter, and a small amount that could affect us in this experiment. So we poured our 5 milliliters of milk, solution number 1, into the beaker. We're going to test it with a pH paper. So we're going to take our pH paper, I'm going to pull out a little bit here, like that. I'm going to dip it down in there. We're going to shake it. And very quickly, we're going to check it and see what the pH is. And you can see it's pretty close to 6. It's not a 7, it's not a 5, it looks pretty darn close to 6. So, on our lab paper, we're going to put right here, under milk, we're going to put 6 for the pH. Okay. Now, step number 3 says, test the pH of the 3 remaining solutions, water, lemon juice, and ammonia, and record your results on a table like the one below. So before we can do that, we have to take our graduated cylinder and we got to clean it. And we got to take our little beaker and we got to clean it. So that's going to take just a moment, so let's get that done. Back, we're going to check our water now. We're going to take a little piece of pH paper. We're going to dip it into our distilled water right there. And we're going to check it on the pH scale, and you'll notice that it's between a 6 and a 7. So it's pretty close to 7. Distilled water is usually pretty close to a pH of 7. Let's see if you can see that or not. Get up here, yep. You can see that it's, if we compare the color there, pretty close to 6.5. I'm going to call it 6.5 because it's between the two, okay? There we go. Alrighty. So on our lab paper for water, we're going to write pH 6.5, okay? Now we got to check the lemon juice, so we're going to set that aside, and we're going to get ourselves another little beaker. And I'm just, in your lab, if you did this, if you have the extra beakers, you could use them. or you got to wash them each time. So now we got to get the lemon juice, and we have to get 5 milliliters of lemon juice. Okay, and we're going to pour it into our graduated cylinder here. So we get exactly 5. I'm going to take out a couple of drops. There you go. Now I'm going to have to wash my dropper before I use it again. Okay, but I'm going to take my 5 milliliters of lemon juice. I'm going to pour it in my little beaker. Get every drop. Makes a difference. Okay. Then I'm going to take my pH paper. Anybody want to guess what it's going to be? It's going to be an acid, but how strong an acid is? What color is it going to be? Okay. I'm going to dip it in there. I'm going to compare it quickly, and it looks like it's pretty close to 5. Okay. So if we look at the pH on our little scale here, which one is it closest to? I would say I'm going to say 4 or 3. So I'm going to call it 3.5. Okay. So on my lab paper, I'm going to write down lemon juice, 3.5. All right, next thing we got to do is we got to check the ammonia. Okay, so the ammonia, again, we have to get a clean graduated cylinder, and we're going to take our ammonia and we're going to pour it into our graduated cylinder here. Now, I'm using a beaker with the ammonia in it rather than trying to pour out of the big container because it's just easier to do. Okay, so I take my ammonia. I'm going to pour in very carefully. 5 milliliters. Got to turn this so I can read it. There we go. Very carefully. 5 milliliters of ammonia. Yep, there you go. Got it in there. I'm going to take my little beaker. I'm going to pour it in. Like so. Make sure I get all the drops. Put that graduated cylinder aside. We're going to take our pH paper. We're going to hold it away from the ammonia until we're ready to use it. Dip it in, and then we're going to check it immediately. And when we look at it, we're going to see we got a definite blue here. It looks like it's pretty darn close to 10. So the ammonia we're using has a pretty close to a 10. Okay, now this is fading already. It's going to fade because over time it evaporates off the paper and it will change color on us. But we know it was a 10 because we checked it immediately, okay? So, on our paper, for ammonia, we're going to write a pH of 10. Okay, so we're back. And you notice the ammonia, the little beaker of ammonia, I put a cover over it so that we can keep the fumes from getting out of there till we want to use it, okay? Okay, that was part A. So in part A, we have the beginning pH of water, milk, which are pretty close together, and there's a reason for that. You're going to see what that is. See if you can figure it out as we go along. The lemon juice, 3.5, and the ammonia, 10. So these are opposites, almost exact opposites on the pH scale. So we got to go on to part B. Okay, part B. Draw the table in your lab book. This is where you will record your results for parts B, C, D, and E. So we got 4 more parts to do. Okay, so in our lab book, you're going to turn to the next open page in our lab book. At the top of the page, we're going to write lab pH and living range. We're going to put our name, period, date up here, part A. What did we do on part A? We put water. Well, I got to change these a little bit. Water was 6.5, milk 6, lemon juice was 3.5, and our ammonia was 10. That's why it's good to use a pencil. Okay, so for part B, okay, now notice on the lab book, you can use a ruler to draw these lines with, or you can do them freehand if you're careful. The pretty little blue lines on here help you keep everything nice and straight. I'll probably use a ruler on some of this, so let me get that done. Okay, very good. So I'm going to need 20 columns going this way and 21 for my labels over in this area here. So I'm going to go like this. I'm going to draw from here. I got that red line. I'm going to go all the way over to here. Now going down, I need 1, 2, 3, 4, 5 rows, and that's why I like these little blue lines. So I got 1, 2. And you want to stay on the blue lines. Mr. Smith does not like things like that where you go off the blue line. That means you're being sloppy and you don't care. So you want to stay on the blue line. Okay. Let's draw it across like that. Next one across like this. Like I said, you could use a ruler. So I need how many going down? 5. So I got 1, 2, 3, 4. I need one more. It's going to go right here. Okay, now it's come right down here. Now on this side, over here, I'm going to put drops. That's what's going to go that way. And the first one here, I have pure water, pure H2O with LJ, lemon juice, okay? Next one, I've got milk with LJ, lemon juice, drops. Next one, I've got milk with ammonia. And the last one, I have water with ammonia. Now I can finish up my lines right here, bring them over. Try to make this look nice and sharp, okay? Like that. Now I need 20 columns going across. So I'm going to measure my columns.